So hello everyone and welcome to another video on CodeCorp. So in the previous video we have a discussion about the abstract classes in Java. So in that video we were discussing about with this analogy like strict parent and chill parent. So we were having some tasks. A task we go for walk and drink water, and these X A B were child and they were implementing that task that has been forced upon them. So be thinking that this like what is the real world example of an abstract class like a strict parent and chill parent. These terminologies cannot be used in the real world projects. So for that I'll just show you a few examples. So firstly you can have a look on this scenario. Suppose you are having one bank account and you are having different types of bank account like saving account, current account, and some other different kind of account. So you have certain one rule to be followed by all the accounts, that is like deposit and withdraw. So every account must have a method that will be related to the deposit and withdraw. So saving account might have been implementing that deposit method in some other way and withdraw method in some other way other than like current account. So the implementation might be different among these between these two different accounts or all the accounts. So implementation might be different, but they need to follow this rule. Like every method, like every child should have a deposit and withdraw method. So here is another example. If you will look at it closely, so here is like another real world example. Suppose you have an application that is dealing with some kind of shapes and all. So you will be creating an abstract class with the name shape, and you will be defining two methods that will be calculate area and calculate peri. That is the calculate perimeter. So you might be you will have an idea like every shape will be having an area and a perimeter. So if you will think like rectangle, circle, triangle, so the method of calculating the area and perimeter might be different, but they all need to calculate the area and perimeter. That is your strict contract that you have imposed on all the shapes. So they must follow this. So here the shape will be the abstract class, and the child class will be following the rule that has been created by the parent class. That is like they need to calculate the area and the perimeter. And similarly in here also, like this is the abstract class and this is the strict rules that it has been created, and these are the child, they need to follow it. Like they are, so earlier I have told you like this method like child A can go for a walk for 200 meter or something. That is the implementation. So here a deposit method might have the different implementation than this current account implementation. So yeah, so I think it will be clear for now. So now we can have a look on the interface part. Yeah, so now we can continue on the interfaces. So just now I told you what are the abstract classes. So these the child classes will be having the methods implementation of these two strictly described methods there. So but what is the additional feature of abstract classes like? So other than these two like abstract methods, I can also have like normal methods here, void normal method. Okay, and this method can have an implementation here as well. Okay, so like what will happen, like if these two classes are extending this parent class, then they will having that the strict rule that they need to have their own implementations of this deposit and withdraw method, but also they'll be having an parent implementation of this normal method. So that also I have told you earlier in my earlier videos. So here you can see in the strict parent we will be having this normal method as well. So when the child is implementing this, then the normal methods functionality will automatically will come inside this. Okay, so now how is the like what is the interface? Now we'll be having the question like if it is functioning like normal abstract class, then what is the interface then? Okay, so an interface is nothing just similar to the abstract class, but it is like providing complete abstractions. Complete abstraction means like it is not providing any normal kind of methods which are returning any string, or like this we have declared here one method and these child are extending it and they'll be having that functionality. So that is not happening here in the interfaces. Okay, so if it is an interface, then it will not be having any normal methods that the normal class have. Okay, so this flexibility, like the methods can have their own implementation. Every child need to have implement them. So that is the main functionality of an interface. So let me tell you what is the syntax of an interface. So just I'll go to Eclipse. I will show you one of the interface. So it is not required. So here you can just define an interface with the interface keyword, and you can define some methods there. And by default, these methods will be abstract methods. Okay, so once you have defined here, then the child classes whatever you are creating that need to override those methods. Okay, so if I am creating any new class here, like child, so like it is saying like child circle. Okay, I'll say like child triangle. Okay, and I'll finish it. And if I will write here like implements shape, then I'll get the notification automatically that I need to implement the methods that I have declared there. So I have implemented here. So now the child class is also a part of an interface of shape. Okay, So in this example, the shape interface method declare two methods, that is that calculate area and calculate parameters. Now, how we don't write the actual codes for these methods, we leave that the classes that implement this interface, that they can write the code, whatever type of code they write need to be written for the calculating area of a rectangular or to calculate the area of a child circle. Okay. One more thing that is an advantage of an interface is like it can provide the multiple inheritance, and it also solves the diamond problem. So you must be thinking like, what is the diamond problem here? We have never heard of it. So diamond problem, I'll explain here. Suppose these are two classes, saving class and current class. Okay, for now, explain it again later. Okay, suppose now these are two classes, saving class and account class. They are two independent class, and they are having these methods, deposit and withdraw. Deposit and withdraw and deposit and withdraw. Suppose for any of the method, like let's say for withdraw, this class is having a separate implementation and this class is also having a separate implementation. Now, if I create a class here, like suppose it is saving class and it is current class, then I will say like hybrid account. I will say hybrid account. So now if I am extending this class from these two, now the compiler will get confused like which of the methods implementation, which of the withdraw implementation I need to consider, because both are having the implementation of the withdraw message. So this is the diamond problem here. So, and how interfaces solve it? Now I have already told you like interfaces do not have any implementation of the classes. So suppose now these two are interfaces. Okay, suppose it is an interface. And for in previous example, it was a class. Suppose now these are interfaces, and these interfaces don't have a definition of these two methods, deposit, withdraw. Now there will not be any confusion. Child need to provide the implementation for the withdraw, for the deposit, and there will not be any confusion. So the Java provides. So this is what Java provides. Like in inheritance, in interface, we can have the multiple inheritance. So suppose this class is inheriting, now this class is inheriting the saving class, saving account and the current account. Now it will be having both of them do not have the implementation for deposit and withdraw methods, but we can provide an implementation after extending these two, implementing these two interface. We can provide the definition in our child class only. So that's why we can say like diamond problem is solved in case of the interfaces. Okay. So now we'll jump to the further topic, that will be both interfaces and abstract classes are providing similar kind of functionalities. So most of the people will get confused, as also interviewers ask this question most of the times, like where to use interface and where to use the abstract class. So I'll provide you some hints, like some of the points in which you can consider an interface, and others in which you can consider the abstract class. So generally the main one of the main difference between abstract class and interface is like you cannot have an instance variable inside an interface. Suppose here, if I will try to declare a method variable here int color shape, or I would say like string color is equal to green. Okay, so this will be a class level variable. This will not be an instance variable, because by default the variables that we declared in the interface are by default static and final. So we cannot provide a getter and setter here. But in the other case, like here, if it is an abstract class, then you can see I have provided this string name, and I have provided the getters and setters also from here. So using any instance, I can set the value of name, I can get the value of name, and I can change it using its getter and setter. But that thing is not possible in case of interface. So I'll explain you with example. Suppose there is a class, this abstract class, okay, and it has a variable, suppose name, or I would say color. I would say color here, and you can change this to you can get the getter and setters of it. I would say change getter and setter. Okay, and I will remove this name and all. And here this will be a constructor. So as you know that interface cannot have the constructor, because what will it initialize, because it cannot have a instance variable. So that's why it cannot also have a constructor, because there is no use of constructor in interfaces, because they cannot have an instance variable, and constructors are generally used to initialize the instance variables. So suppose I have declared here, and I have declared a abstract method as well. Suppose here I am declaring this public abstract double KLC area. Suppose I have declared this. Okay, and get color set color I have already provided. Suppose now there is one shape that is circle, and circle I will firstly remove everything from here, and suppose so it will ask me to implement the by default method from there. This it will ask me to provide, and its circle I can provide the side, like suppose radius of the circle, private int, I will say double here as well, double radius, and I'll provide the getters and setters. And here also, like, I'll provide the constructor of this shape class, shape, not a circle, and I will say like string color and double radius. And here I can initialize the constructor of the superclass. I can implement that, and here the radius I provide. So just for now, ignore all these methods because I'm not using them. I'm just using here calculate area functionality. So others I have declared, but I am not using for now. So what by the state of an object means, like how the state of an object will get hold by a parent class. So suppose if I am declaring an object of a shape class here, shape h1 is equal to new circle. I will provide yellow, and here I'm providing any radius 4.5. Okay. And if I will call like s1 dot get color method from here, so you can see from here my shape class is holding the state of this object s1, and it is setting a color to that as well. Okay, so this thing cannot be done using interfaces because we cannot define an instance variable, because you can see from here the data is going to the circle, and from here it is getting like a new object has been created and the value of the color has been assigned to it as yellow. So if you will see in this example, in this example, the shape abstract class holds the state of the shape object using an instance variable color. So if you will see here, so here you can see in the main class it is holding the state of this s1 object with the color yellow, and yellow is the instance variable that has been declared in the abstract class. So means like now this instance will be having this variable. This variable has been provided to the s1 object as well. Earlier it was a part of the class only. So this object has not been declared in the circle. The color variable is not available here, but here you can see this is the color variable is available here. Okay, one more thing. Whenever a class is extending another class, then you will most of the people think like only the methods are available to the child class. The methods of the parent class are available to the child class, but that's not the scenario only, because with the methods, all the variables are also provided to the child class. Most probably, like if it is a private variable, and if it is a protected variable, then also it will be available to the child classes objects. So that's why they are called instance variables. So here, if there is a variable I have declared in the abstract class shape as color, then this variable will also get provided to the circle class or rectangle class. For every class, the shape the color variable will be there, and the shape class will hold the value for that. Okay, so here you can see in the main that I have already told you, like yellow variable, the yellow value will be assigned to the class level instance variable, not the object level, because in the child class I have not declared that yellow variable. So there is one more scenario, like although we do not have the instance variable in an interfaces, but for these normal kind of methods that I have told you earlier, like the normal methods that are available in the abstract classes here, like if I declare a normal method, then that method will be available to the child classes. But similar to that, we do also have one thing in the interfaces, that is default and static variables. So suppose this default variable is there, and you have you can provide the implementation to the default variable as well. Okay, so now you will say like, what is the difference between abstract classes and interfaces with default methods? What is the difference now? So now for that purpose, I have like created one slide, the PPT slide that will most probably define all the differences between the interface and the abstract class, or I would say like the interface with default methods and the abstract classes. So here, if you can see this, so here I have just defined few of the points. So firstly, inside abstract class, we can declare instance variable which are required to the child class. Okay, so here for the first point I have already mentioned to you as well before. So inside interface, every variable is always public, static, and final. We cannot declare instance variable inside an interface. That I have already informed you. So here another one thing is, like abstract class can talk about the state of an object. The state of an object, abstract class can only talk about it until and unless it have the instance variable. If any class does not have the instance variable, that it cannot provide, or it cannot define, it cannot talk about the state of an object. So here the point 2 is stating that is also not possible in the interface because they cannot have the instance variable. And the third point is, inside abstract class we can declare constructor, okay, to initialize the instance variable. But inside an interface, when we do not have the instance variable, then what is the need of the constructor? If we cannot have the instance variable, then there is no requirement of providing a constructor. Okay, and the third point is, inside abstract classes we can declare instance and static blocks. Okay, interface cannot have instance and static blocks. Okay, So those are basically class level blocks, and we do the things which are required for the instances and the class level. So that is also not available for the interfaces. And one more thing, like inside abstract class, we can override the object classes methods, because object is also a class and interface is not a class. So the object class method are not available for any of the interfaces, like as hash code method, equals method. Those methods are not available for the I would say for interfaces. And lastly, abstract class allows single inheritance, where class can extend only one abstract class. Okay, interfaces allow for multiple inheritance, that I have already told you the reason behind, because of the definitions that has not been provided in the interfaces. Because of that, we can achieve multiple inheritance. Okay, so now again, if you are having any doubt, like where can we use, like this is all theoretical. Now just give me a something logical answer, like something logical that I can get in my mind, like where can I use interface and where can I use the abstract class. So I would say, like wherever you are working with the like I would say unrelated classes, then you can use the interface. And when you are working with the classes that are highly related to each other, in that case you can use abstract classes, I would say. So for this one also, I will give you a simple example. Suppose I have an interface label, okay, and I have one abstract class, that is audio content, and I have three content that are I would say songs, I would say podcast, and one is audiobook. Song, podcast, audiobook. So if you will see closely, then all the things, these three things are closely interrelated to each other. Okay, so that can come under an abstract class. As I told you earlier, for all the related classes, you can go with the abstract class. So here you can go with the abstract class, because all the things are very interrelated, and if they will be having the similar kind of functionalities. So you can go with the abstract class here. You can create an abstract class named audio content, and you can make these class extend that abstract class. So suppose I add a new kind of like something unrelated thing to them. Suppose I have added one more class name here, that is video. Okay, so now these classes, so now you will see like these classes are not closely related, because this is an audio content, this is an audio content, this is an audio content, but this is a video content. Okay, then what will you choose? So in that scenario, you have to go away with the abstract classes, and you have to choose an interface, because I told you already, like interface can cover all wide range of unrelated classes. So you can have something like songs, podcast, audiobook, video, but if these three are not interrelated, then you can go with the interface. So I hope that will clear all the doubts where to use the interfaces and where to use the abstract class. Most of the doubts I think will be cleared with this example if you will go through it. Okay, so just for recap, like all these three classes, if we are having three classes that are closely related, then we can choose abstract class. And if we are having the unrelated classes that are not closely unrelated to each other, then in that case we can use the interface. We can give it a common kind of name, like any general name, like that I have given here, like playable. So I have given one playable name, and you can see everything is playable here. And if those are closely related, then I have given a name as audio content, and it is getting more specific now. So only the audio contents related methods will present inside there, and they'll be implemented inside this content. Okay, so I think that will be enough for the differentiation between abstract classes and interfaces. So hope to see you in the next video, that I'll be confirming like what it will be about. So I think that is all for the interfaces and how to create an interface, or what are the uses of interface. I've already explained that. And now what are the default methods and interfaces, I have also explained that. And why do the default methods came into the pictures? That is only like if some classes are implementing the default interface. So, okay, let me give you an example of this also, like what are the default methods and interface, why do we need them? So suppose there is one shape. Okay, so now I would say like every class is implementing this shape method. Okay, and they are not having any issue with that. Suppose I have introduced one method here, void start, void geometry. I have declared one method here. Now you will see all the classes that were implementing this interface that will get into the error that you need to implement this interface, or this newly created method. This newly created method need to be implemented in the classes which are implementing this interface. So for that, to avoid that scenario, what we did, like what the Java people did, like they just declared that method as default, so that it cannot break the existing implementation. So if I will write a keyword like default here, then you will see then any of the classes will not give any error related to that. And in default method, we need to always give a body. So here you can see, like I have added one method, I have done whatever I wanted with that method, and still my code is working and nothing is broken. So for that scenario, the default methods were introduced in Java 8. Because most of the collection framework has changed, like some methods has been introduced into the collection frameworks and all, then there might be an issue like with the existing class. I would say list class. Suppose list is implementing this interface, that is collection. So suppose I have done any changes in collection interface here. Suppose I'm declaring one method here. Then what it will do, it will break. So suppose I have done any changes in collection framework. Okay, I have declared any of the method and I want to do something new with the collections. Then what the problem will arise, like these classes that are implementing it, like list is implementing the list is extending the collection framework, the collection interface, then list will start giving error. Similarly, the child circle and child triangle were giving error. So for that purpose, everything that they want to do, they have put that inside a default method scenario, and they have introduced that new functionality of default interfaces. So if you will see, you can see here like to array, we can convert a collection to an array using default methods they have provided. So in that way, that like list will not get break, and that will collection will do its work. The default methods will do its work, and it will not break the existing classes. So that's the main problem that was solved by the default using defaults methods. So I think I have covered pretty much all and everything related to the interfaces. So we'll meet you in the next videos. And if you have any doubt or any questions, please provide them in the comment section. And if you like the video, don't forget to like it, share, and subscribe. So that's it for the day. We'll meet you in the next video. Thank you.